The challenge in selecting liquid filtration equipment and the optimized filters is determined by factors that make the most technical and economic sense for each application and which supplier is best qualified to provide products in a timely manner. With us again is Principal Engineer and Filter Designer Michael Goldman to elaborate on how to select a liquid filtration design.
Accurate selection of proper system and filter media for your application can be very important. For instance, does it meet your technical goals and objectives? Consider the following parameters. Any of these factors independently or in combination can impact results.
Why is the pore size rating essential?
The pore size rating of a filter measured in microns is the diameter of the smallest particle that can be expected to be captured and retained by that filter.
You also mentioned efficiency levels.
Yes. The efficiency of a filter relates to the percentage of effectiveness in removing particles of a specific size and the ability of the filter to capture and retain particles at the rated pore size and larger. This rating can also be called nominal with a range of 50 to 90% efficiency, or absolute rating with a range of 95 to 99% or higher efficiency micron rated pore sizes. However, it is critical to research the definite efficiency rating conforming to ASTM, particularly ISO 4406 liquid cleanliness standards. Additionally, efficiency, sometimes expressed in terms of beta rating, which is the ratio of the number of particles entering a filter at a specific micron size, and larger versus how many will pass through the filter. As shown, a higher beta ratio indicates the removal of a greater number of particles at a given size and larger, and therefore a higher efficiency.
Okay, next was particle loading regards to size and distribution.
Loading is defined as the filter's ability to capture the greatest amounts of solids before blinding. The goal is to find filtration optimization, which is the proper balance between underfiltration, too coarse with inferior performance, and overfiltration, too fine, resulting in excessive media changeouts to accomplish objectives with satisfactory economies.
One important factor indicated was viscosity of a liquid, flow rate, and pressure drop. Here is the fluid viscosity chart. Please explain.
Viscosity measures the thickness of a liquid or ability to flow relative to water. With higher viscosity and greater the load on a filter, the flow rate reduces and increases the pressure drop, thus shortening the useful life of a filter. Therefore, it's vital to decide filter media size, and proper surface area.
Can you explain the difference between chemical and thermal compatibility?
Here is the chemical compatibility table. Chemical and thermal compatibility shows the degree to which our materials can withstand a range of chemicals and temperatures without sacrificing structural integrity and media deformation.
Even when combining all discussed, there's more that can influence the decision. For example, how can the total cost of filtration be affected?
The total cost of filtration is determined by many components. To mention a few: capital equipment and installation costs, filter media disposal cost, cost of wasted product, and others.
So with precise decision making, companies can save costs on filtration. Environment and sustainable objectives are another important element. Can you expand on them?
Yes, from an energy consumption standpoint, attention should be paid to the initial clean pressure drop of a filter. From a water consumption standpoint, consideration should be given to wasted water, such as the need or requirement for filter backwashing, and chemical consumption, which is excessive use of costly chemicals for treatment.
Okay, and what about the system meeting delivery requirements?
Here are a few things to be considered: timely design recommendation, timely delivery of full-scale system, timely delivery without disruption of consumable filter media.
Understood. Thank you for going into depth about that. In summary, selecting a liquid filtration design includes understanding the filtration objective both technically and economically, characterizing the liquid and solids to be filtered in the process, identifying the flow rate, identifying the available feed pressure and required minimum outlet pressure, micron rating and efficiency, and thermal and chemical compatibility. Thank you, Michael. This was very helpful and informative when deciding on a liquid filtration design.